Hi, my name is Jacob Bartlett, and this is my second milestone video for ECE 4910 as part of the Sandia Labs Clinic project. For my second milestone, I took all the electrical components that were part of my first milestone to spec out, including power supplies, stepper motor drivers, control board, and other components of our project, including the Keyence laser and power supply, and designed an enclosure for them. I originally was going to actually build the enclosure myself out of acrylic, but as a team we decided a pre-built metal enclosure would be better because it will have to be palletized and shipped back to Sandia eventually, and there's a high chance the acrylic would be damaged during the shipment. The enclosure is quite large. It's 24 by 24 by 12 inches and has not yet arrived, unfortunately. It is due here any day now. So in the interim, I decided to go ahead and start learning a bit of SolidWorks so that we could play around with how to arrange the components within the space that we're going to be having, while also getting a realistic sense of how everything would fit and how to properly vent it. So here in SolidWorks, kind of gives you an overview of what I've designed here. You can take a look. This is kind of an overall shot of the entire enclosure, including the vent holes on both the door and the side, and you can see some of the top components that I'll zoom in here on a minute. There will probably be a few more holes in the top panel as well as more components that will be added throughout the project. We're not quite finished gathering everything that we'll be needing, but for what we have on hand now, these are the connections we have planned. So here's the layout inside the enclosure. You can see here all the different components. We have here 6 stepper drivers along with their fans on the side pointing towards the outside of the enclosure to allow for that venting that you saw on the side. Here we have 3 different power supplies. 2 of them are 60 volt DC power supplies for driving the stepper motor drivers, as well as this 5 volt supply that will be used for the board. Here's the control board as well as a daughter board that allows the connection to happen through Ethernet. Unfortunately, after getting this board as well as receiving our workstation from Sandia, we ran into a problem of compatibility with the program we're using. So this board may actually have to change, but as you can see, we've got plenty of space to work with to arrange the board differently and allow all those wiring and connections to happen. Up here you'll see the Keyence laser hub as well as its power supply. And of course we needed to put these close to the top because this is where a lot of the wiring will come out, and we need that cable for the laser. It's fairly short and it's pretty expensive, so we want to reduce the amount of cabling needed for that as much as possible. You also notice that the fans are directed away from the control board as much as possible so that it doesn't heat up the components that should be staying quite cool. Now on the side here, I wanted this enclosure to be as functional as possible and to resemble quite closely a computer case where everything has an external connector so that independent cables could be used to connect to the computer and to the CNC machine and not require any cables hanging out during transport. So here you can see 2 different outlet connectors that'll be for those power supplies. And we may have to add a third for the actual power supply for the Keyence and any other power supplies that are added later on. Here on the top you can see, I'll zoom in here a bit, we have 2 USB ports as well as an Ethernet connector that will be used to connect to the board as well as to the Keyence laser to gather that data. We may have to add a few more as the rest of the sensors are chosen and arrive. I added a nice e-stop button here because you never know when the sensor head might start running into the part being scanned, and we want to be able to stop and shut that down quite quickly. And then over here I've also added some XLR 4-pin connectors. Each of these will be connected to the stepper drivers and each one will represent an axis. I wanted all these to be just laid out so that anybody could walk up and see how to start connecting this machine and not have to worry about wiring up each individual stepper and each individual power supply. So I wanted it to be quite like a computer case in that fashion. Finally, the station itself is supposed to be mobile, And so I thought it would be a great idea, since this enclosure is the size it is, to go ahead and add some caster wheels on the bottom so it can be rolled around. Originally we had planned on mounting this on the side of the scanning cage, but as this thing will weigh well over 50 pounds, I wouldn't be wanting to heft that up and down very often, so I thought the roller wheels would be a better idea. So there it is. Thank you for watching.